Warm-up quiz, A, B, C, or D. Choose an answer and bring it up. Answer is D. Number 2. Answer is D. Number 3. Answer is C. Last one, number 4. Pick a number from 1 to 20. Winning numbers today are 4, 6, 8, 11, and 13. Multiply 2 by 2 matrices and other dimensions. Example 1. Alright, here's an example. This is 2, 3, 4, negative 1, and multiplied by 6, negative 2, 0, 5. So if we're going to multiply this one out, we have to start here, this row and this column. We're going to put our answer over here. So if we go row 1, column 1, it would be 2 times 6 plus 3 times 0. And that's 12 plus 0, which is going to be 12 in the first row. Does anybody not understand how we came up with 12? Alright, so we'll go with the first row still, but now the second column. So that would be 2 times negative 2 plus 3 times 5, which is negative 4 plus 15. The answer is 11. Does anybody not understand how we came up with 11? Alright, so now we'll go with the second row. We've exhausted the first row with the second matrix, so we'll go to the second and do the first column. That one would be 4 times 6 plus negative 1 times 0, which is 24 plus 0. The answer is 24. Does anybody not see how we came up with 24? Alright, so we'll go with this one to finish off, this row and this column. That should be 4 times negative 2 plus negative 1 times 5. Negative 8 plus a negative 5 is a negative 13. Try this one and bring it up. Matrix 1 is negative 3, 0, 4, 2, and the second matrix is negative 1, 5, 0, negative 6. This one, let's see, it should be negative 3 times negative 1 plus 0 times 0. So that would just be a 3, and we'll dump that in there. The row 1, column 2 should be negative 3 times 5, and then 0 times negative 6. Of course, when you have a 0 in there, it's going to cancel out. So we have a negative 15. There's the top row. And now we go to this one, and then to this one. That would be 4 times negative 1 plus 2 times 0. That's just a negative 4. And the last one, second row, second column, should be 4 times 5, and then plus 2 times a negative 6, which is 20, plus a negative 12. That would be an 8. Here's an example for different dimensions. The rule you have to remember is that if the amount of columns in the first matrix equals the amount of rows in the second matrix, then you can multiply. It would be yes. If the number of columns in the first one does not equal the number of rows in the second one, then the answer is no, you cannot multiply. And all we'll do for our first examples for this is just answer yes or no. Can it be multiplied or can it not? if it can be, then you have to work it out, right? So on this one, let's say we have 2, 3, 4, and then 6, 5, 2 in the first one. And then for this one, we have 5, 6, 7, 2, 3, 5. How many columns are in the first one? How many columns in the first one?
3 in the first one.
3 columns in the first one. How many rows in the second one? 3 rows. Columns go this way and rows go this way. So they match up. The answer is yes. You can multiply it out and then you would go work it. Here's another one. 1, 0, 2, 3, 2, 6, 4, 5, 7, 1, 6. How many columns are in the first one? Yeah, we have 3 columns there. How many rows in the second one? 2. 2 rows, 3 columns. That does not equal up, so you cannot multiply those together. Here's another one. 4, 6, 3, 2, 1, 7, 4, 8, 2. And in this one, we'll have 3, 4, and 6. How many columns in the first one? We have 3. And how many rows in the second one? 3. So that one would be possible. Here's example 4. This one is 3, 6, 7, 2, 4, 5. And this one is 2, 0, 0, 1, negative 1, 2. Would it be possible to multiply these two together? We have 3 columns in the first one, 1, 2, 3, and 1, 2, 3 rows in the second one. So yes, you could multiply it together. Now, the dimension of your answer matrix is determined by what you're multiplying together. So it's already done for you. So you're going to have this row multiplied by this column to start with. So you're going to have a row 1, column 1 in your answer. You do this the same way you did 2 by 2s. For this to start off with, you would have 3 times what? 2. And then plus 6 times what? And then what 2 do I multiply together? 7 and negative 1. So that would be a 6, 0, negative 7. 6 and negative 7 would be negative 1. So we have to find a place to put our answer here somewhere. So we'll do this for a start. And that's negative 1 because it was row 1, column 1 that we multiplied together. So let's stick with row 1 and then do column 2. So that would be 3 times 0 plus 6 times 1 plus 7 times 2. 0, 6, and 14. That would be a 20. So we're done with all the columns in the second matrix. There's nothing more to do with row 1 over here. So we go down to row 2. And then start over again with those 2 columns in the second matrix. So that would be 2 times 2 plus 4 times 0 plus 5 times a negative 1. 4, 0, negative 5 adds up to be a negative 1. And then go to the second column and get 2 times 0 plus 4 times 1 plus 5 times 2. 0, 4, and 10. 14. There are no more possibilities to multiply out, so your final answer ends up being a 2 by 2 matrix. This one is, if you look at rows and columns, this one is a, oh, I can't delete backwards. Rows 2 and columns 3. This one is 3 and then 2 for columns. So if the columns match up with your, actually the row here, if it matches up with your column, chances are you'll have a 2 by 2 answer matrix. Alright, to see if we can do this or not, we have 2 columns in the first one, 1, 2, and 2 rows in the second one, so we can multiply these together. Therefore, you're going to have 2 times 4 and then plus 3 times 2. That is because of this and this. And that's an 8 plus 6, which is 14. So we're going to put a 14 down in row 1, column 1. And then this same row times this column, you would have a 12 and a 3, which is 15. And then that same row, you would have a 6 and a 15, that's a 21. Then, moving to this row, in the same columns, you would have 16, let's do that in white. 16 and 14 is 30. 24 and 7 is 31. 12 and 35 is 47.